G'day everybody, where's Wally here?
How's that possible?
Error, wrong, illogical, nonsense.
I still can't believe it.
For me, it still doesn't make any sense.
The shortest distance between any 2 points on a sphere is a great circle route. Now, is that true?
Oh, I do miss listening to Bev and Paper and the gang just trying to cope with maths that is well above their capabilities. Now, PD194 has them in a state of mental flux. Yes, they're mentally fluxed right up. So enjoy PD194's latest video where Bev and Paper are climbing Mount Stupid without ropes or safety net.
I'm glad we're having this coordinate lesson. It's quite good. I like it. It's just too much for, us normal brains to comprehend. And to be honest with you, and we are simple folk.
Now, don't watch it all on my channel here. Pop over to Petey's channel and give him a view and then a subscription and then a comment for the almighty algorithm. And the link to it is in the description of always, if I haven't remembered to put it up here at the top. And yes, there is Wally's CNC adventures at the end of this video if you're so inclined. Thanks, guys.
How's that possible?
Error, wrong, illogical, nonsense.
I still can't believe it.
For me, it still doesn't make any sense.
The shortest distance between any 2 points on a sphere is a great circle route. Now, is that true?
No, of course not.
Can you actually have 2 points that aren't on a great circle? The shortest distance between the two? What about if you have 2 points that are on the latitude? Would you say that the shortest distance between those 2 points lies on a great circle?
Absolutely not. Never.
How is the shortest path between 2 points on a sphere following a great circle? Even if they're on the same latitude, how could the shortest distance between those 2 points be a great circle distance? Because a great circle requires the maximum size of circle, doesn't it? To be yes. A great circle. Well, how could you possibly have that maximum size circle if those 2 points are on a latitude that's not the center?
Yes, I agree. So this is, it cannot be.
It's a false statement, quite clearly.
False statement about great circle.
Yeah.
You can have great circle, but
not necessarily the shortest distance between 2 points on a sphere. And that's in reality. You can prove that in reality. On a ball, a Euclidean ball. If you try and compute them, you get into problems. You end up nut-sacking yourself. If your mathematics teacher is more inclined to this non-Euclidean type, new modern mathematics, then you can understand it being a load of nonsense.
So that audio was from the Try Thinking YouTube channel, and we had Bev and the paper organist there discussing whether or not the shortest route between the 2 points on a sphere lay on a great circle, even if those 2 points occupied the same latitude line. Now, this was quite an easy one to test. We have our points A and B sitting on the 50° north latitude line. We have a red arc here, which is part of this latitude line, and we have a blue arc, which is part of our great circle. Which one is the shortest distance? Well, it's difficult to tell just by looking at it, but luckily for us, I put the distances up here. The great circle distance is shorter than the latitude distance. And this is going to be always the case no matter where we put these points. The great circle one is always shorter than the latitude one, unless of course it's sitting on the equator, in which case they'll be the same. So no matter where you put these, doesn't matter which latitude line you pick, the great circle distance will always be shorter than the latitude distance.
He did it! It's genius. He did well there. I'm glad we're having this coordinate lesson. It's quite good. I like it. It's just too much for, you know, us normal brains to comprehend. And to be honest with you, and we are simple folk. Do it again. Like, do it again, please.
For me, it still doesn't make any sense. Doesn't make any sense.
Yeah.
So it is just nonsense. Impossible.
Tis globe. Stay globe. Tis globe. Tis globe. Tis globe, after all.